Hey, this is Joe Burnett. I'd like to talk to you about GitLab steps. There's a blueprint for defining steps, and I've been working on the runner part. And I've written it up as a blueprint. I have a merge request, which is linked in the description of this video, but it's kind of complex and it's a big departure from the way the code is structured around the inside of Runner. So I wanted to do a little walkthrough of a code prototype, so you can kind of get a look and feel for like how execution with Step Runner looks. The two kind of go hand in hand. They're kind of companions. The merge request and this video kind of touch on the same topics. There's a little more in the merge request in terms of context and details, but it's you could start with either one. So we want to build steps as a way to make the GitLab syntax a little bit more simple. It gets kind of complex adding new features. We want to make pieces of the workflows reusable in the same way that GitHub Actions are reusable. We want to make them distributed with the CI component catalog. We want to be able to sort of decouple the runner a little bit and support more and varied things, but to do it in a versioned way that are, separate from each other so that you can, specialize each of the pieces a little bit more. And runner's a little bit of a tightly coupled binary. And, there's some things that we want to do with regard to making the runner manager less stateful, so it can survive things like a restart without having to start jobs over. So like this is a stepping stone for a couple of things, but one of the things that we get out of it that has a lot of product value is compatibility with GitHub Actions. It'd be lovely if you could, there's a whole marketplace for GitHub Actions out there. It'd be lovely if you could just point to one and say, hey, I want to do this, and put it in your GitLab workflow as one of the steps. So that's kind of what I'm going to show you here, is how that would work. Yeah, so Step Runner is a new binary, and it's in the job execution environment. So you have the manager, and then you have the runner where it actually runs the job. This is actually in the environment, the target environment. So there'll be different Golang binaries compiled for each architecture, etc. It is given a job, and this job is defined in proto. And the job sort of is, sorry, the job's not defined in proto necessarily. The job's actually a JSON blob from the CI. It's in that CI syntax. It's like, step this, step that, but it has sort of like some nice user, friendly syntax. The first thing that the step runner is going to do is it's going to translate that into a proto syntax that it operates on internally. And there's a couple of reasons for this. Having a consistent proto to operate on internally allows like there to be less impedance mismatch between different parts of the system. It gives us sort of a standard interface for when we bring things from the outside, like external components, external engines, etc. And it's just a nice sort of way to transform the data from whatever user-facing thing we want to, you the way that a user would want to describe their work. It's nice to have that move independently from the way that the system operates so that we can have a more stable system. So I'm not going to show the translation. We don't even actually have, we haven't really defined exactly what that syntax is going to look like. That will come later in the blueprint. I'm picking up with the proto. I'm picking up with the part that the machine operates on. And here's an example of what this would look like. This one's in JSON, but I'm going to read it into a protobuf. Basically, it's just a list of steps, right? And it has a name for each one. It has a little pointer to where the definition for that step lives. So a location will be a URL or a path. The version is like a tag, something that's like mutable that you might want to grab a different version of. There can also be a hash. You can put a hash here or in another field. You need to tell it what type. And this, we can kind of like pull it and see what's there and try to guess, but it's better to be explicit. So we're going to say explicitly, this is a GitHub action called, setup go. And we also provide a method for how you should actually get that component. There's a couple things you could do. You could pull it from a Git repo, you could download a file, or you can just find it in your local file system if you choose to bake them in. We give it an environment, like these are the variables that it needs that we provide, and we give it an input. And the input here is, Go version 120. And we don't have any outputs defined at this point. So this is like a function call. So this is where we pick up. All right, I've loaded this file. All right, so I've started this running, and I'm going to continue. And we hit this first step right here, run. And what do we have? If I print the job, you can see that it's a series of states or a series of steps. And if I look at the steps, you can see that it's basically the same structure as the JSON blob, right? Components, the input, output. I just read that right into here. Okay, so the first thing we're going to do is we're going to get an environment that we can mutate. And we're going to take this step, and we need to actually figure out all the details about how to run this thing. So there's two significant phases on the inside of this. There's fetching, right, which is like resolving that reference to, the remote component, getting it here, loading it, and looking at it. And then there's the expansion phase, which is like, okay, great. This thing requires me to do something. That something is going to expand into additional steps. Now, at the end, we actually have to do something. So StepRunner has a module or a package called engine. An engine is a HashiCorp Go plugin, just like Fleeting, that is able to do one specific kind of thing. There's an engine for pulling sources. There's an engine for running Node. And these engines, they just do one thing, and they do it without regard for how they're configured, right? An engine does not know about a GitHub action or a GitLab step component. We're going to define something like an action natively to get in GitLab, but it'll be some other syntax. Maybe we'll have a different calling convention or something. I don't know. It doesn't matter. The engine doesn't need to know about that. All it needs to do is get its inputs and provide its outputs, right? And those are going to be called out explicitly. So we have to take this component here, right, which is this GitHub action, and we need to expand it until all we're left with is engines. That's the expansion phase. It's just like, okay, these are the actual things that I need to do, and then we're just going to exec those engines one at a time. So as I come in here now, I'm just going through all those top level steps, right? There's only one, so it's a simple case. I'm going to go into resolve engines, and here we're entering a switch based on the type of component there. And of course, it's not unknown. It's not an engine. It's a GitHub action. So we are going to cache all the components, because we may pull the same component multiple times. We may use it multiple times. So we get the actual component through the cache. And here it actually was pulled the action, right? And it put it somewhere. See, we put it right here in our temporary directory. in step components. So now we have the action here. That's super great. Now I'm going to read it, right? So this just means like go to the file that I know is there, action.yaml, and read it into a Golang structure. And GitHub Actions have inputs defined, outputs, and a runs block, which explains like how you should run it, like what kind of environment does it need, etc. For example, this particular action runs in Node, right? Like setting up Go was this was all coded up in Node. So I need Node 16 to run this thing. The inputs are all these things that I define. You saw I specified Go version, but the others are optional. So like if you look at the inputs, many of them have defaults. So I've got this action, right? And that now I'm going to need to do the expansion phase because I got to get all the way down to engines. So I'm building up this sort of execution tree. So it's going to have children. This action specializes in GitHub Actions. So it knows like how to expand specifically for executing GitHub. So here I have a case for Node 16. So, like when I implement running using Node 16, I'm going to take the same inputs and outputs, and I'm going to transform them. I'm preparing them to call a GitHub action because there's a specific call convention. All of the inputs for an action are provided as environment variables with a prefix, inputs underscore whatever the variable is. So all the inputs are just environment variables. And the outputs are taken from either a file. So like you provide an environment variable that points to a file, and then the action runs, and as it produces outputs, it writes them to this file. And so I go back afterwards and read that. If it wants to export environment variables, it does the same thing to a different file. And an older legacy way of producing outputs is a special syntax for printing to standard out. So there's some specialized post-processing that needs to happen here too. So I'm going to do a bunch of setups specific to GitHub Actions that the engine doesn't need to care about. One of the things that I'm going to do, so let me just get through this list real quick, and I'll walk you through each of these functions. So one of the things that I need to do is interpolation. So each action has a pre and a post step. So like with a node, you could run 3 times. You could run pre, the main, and post for like cleanup or something. But each one of them also has a predicate associated with it, the pre and the post. So you can run the post step if it's this or if that, etc. Or you could even run the whole thing if or else that. So that if or else can refer to previous steps. It can refer to other things in the environment. So I need to do this. I can't do this during the expand. Sorry, I need to. Actually, there's 2 interpolations. I just got them confused. This interpolation is actually for the definition of the environment variables themselves. So actually, like when you inject an environment variable, the value could contain a reference to a previous step. So like a previous step could like do something, and then like it could inject a pointer to that in a value later on. There will be like pre and post expressions to evaluate later on during the execution phase. But this first interpolation is actually just for like the actual concrete values that go as inputs in environment variables. So we do that, and then we need to provide some default inputs. So remember how that action definition had defaults for some of them? We actually need to the expectation is that we set all of those, right? The engine's not going to. The engine just needs the inputs that it does. The code doesn't even have those defaults. They're only defined once in that action.yaml. So the caller is responsible for setting those defaults. So we don't really need to see that. Then we're going to validate it, make sure we actually have all the inputs. You can see here that I haven't finished all of the details. And then this is the calling convention I was describing. We're going to prefix each input with input and put it in the environment variables. So this is something interesting about the components here, the intermediate components that are not engines, like the GitHub Action, is they actually consume all of those inputs and send them into the engine as environment variables. And this allows the inputs themselves, like when you call the engine, the inputs can be used then, the empty inputs can be used for providing parameters like where to run. You'll see that more in just a minute. Okay. The one step I just skipped over by accident was set up outputs. This is where you would actually create a file for the outputs and then set that as an environment variable with a pointer so that GitHub action knows how to write to it. Now the engine is just running this node code, and it's the node code that knows the calling convention, how to send stuff back out. So the engine doesn't need to know about GitHub Actions. Okay, here we go. So now we have, we're providing inputs to the engine. So here we're going to say, okay, here is a main function, and we're going to point it to whatever file the user specified. And we're expanding this action into an engine. So it's going to be another component, but this is the version of the node engine that we want to use. And in this case, it's provided locally. You'll see here that the type is engine, and I've provided a local component right here in this repository. I have another folder where I have this engine built, and it's just pointing to that. But you could pull the engine down remotely. It could be from any of the normal places that you'd find a component. I mean, engines are components, so you distribute them in the same way. Yeah, so as we come back out of here, I kind of want to show you what our tree looks like. So this is our tree. We've got the first step. It has a path to where the component lives, right? This is going to be the working directory, because that's where all the node files are. But it's not an engine. So we're going to instead print we're going to take a look at the first child. Children. Now this one does have an engine, because this is one of the leaf nodes, and this engine points to. So we have another path here, which is where the engine is. This is where this Go plugin is, right? Because we actually have the plugin, and then we have the code that it's going to operate on. So here's the plugin, here's the code, and it has these environment variables. So if I look at engine environment, you can see I've got all the things there. And if you look at the engine inputs, you can see this is what I'm communicating to. This is what I'm communicating to the engine as to what file to run. Okay, so here we are. This completes the fetch and expansion phase. So now we have like a tree of engines. This can get more complicated because some GitHub actions can be composite actions, which is instead of having this runs this file in Node, it could say it runs these actions, and it'll have a list of actions, like a miniature workflow. And so this fetch and expansion phase needs to go through, and each one of those actions, it needs to pull that reference, open it up, see what's there. Might be a composite action. I don't know, like we just kind of need to expand this into this tree of execution. But at this point we have, so the next phase is execution. All right, so we're going to run each of these top level steps, which are now represented by a tree ending in engines. And there's a base case, of course. If we're an engine, then run the engine, but we're not, right? This is that top level one that just sort of defines the context. We're actually going to go into the recursive case here. And for each of the children, we're going to call the run engine again. So this one, remember there was a one child, and that one child was an instantiation of the node engine. So now we're in the engine case, right? So we have another cache for engines, right? Because the same engines are going to get used over and over again. So in the same way that we had a component cache, we have an engine cache. This engine is local, so there wasn't any network call needed. It's cached by that component. Both the systems, as a matter of fact, it's the same cache. And all it does is it uses the location, the version, and the hash as a key, and it pulls it down and puts it into a temporary folder for you, and returns the path. So we have a pointer to the engine now. And we've actually instantiated it. Yeah, there was a whole piece here where we instantiated the engine, that I do want to show you. So I'm actually going to, I want to go inside that function because there's some interesting stuff inside there. So I'm going to kind of restart this process. We normally clean up when we exit, but I just had to blow it away since I restarted. And I'm just going to jump back down to here. We're going to go inside, run engine, get the engine, recursive case. So here for the children, stepped past it again. Can't believe I did that. Bear with me. Don't type and talk at the same time. All right, come on. All right, I'll get you back there in just a sec. All right, so we're running the engine. That's great. I could probably set a breakpoint in the right place, but I'm going to have one more go. All right, getting the engine, stepping inside here. All right, so we have the engine path, right? And we have a little local cache of processes, right? Because this is actually going to be hanging as a process right off of the main step runner. It's not okay. We don't have one. So I'm going to run this plugin. And run plugin actually starts this binary. You can see over here, this looks just like fleeting. Starting the plugin, communicating it, everything's happy. And if I just look over here and I look at my process tree, you can see this is me in Delph on the actual binary running. And you can see I have an engine hanging off of here now, which is Node.js. That wasn't there before. So I'm actually going to connect to it because I want to continue the debugging. I want to show you the step build process all the way through to where we actually call Node. So where are you? Node.js is this process. So I'm just going to call delve attach. And I'm going to set a breakpoint here. So I'm going to let it continue running. So this process is running in the background. And this kind of brings us back out of that get engine case. We are now creating a request This is the proto. So the engine, so the steps definition, that internal structure that we sort of iterate over and operate on, it's the same proto that the engine takes as input. And this is done on purpose. In addition to sort of making things easier to translate, right? Less impedance mismatch, like you don't have to keep putting data into the same shapes. It also allows you to take engines and plug them directly into workflows. And this allows things like get sources doesn't need an outer component, right? Like it can just be an engine that we expand to during that translation phase. So we're taking this engine, we're parameterizing it with a bunch of stuff, giving it, the inputs, the outputs, the environment. Now at this point, it's all fully resolved. So engine's just gonna run it exactly as is. And I'm gonna step over eval. Now you notice we got caught over here. So this is where it actually makes the function call. This makes the remote procedure call through that socket over through the standard, in and out over to the plugin. And I'm now in that Node.js plugin, and I get the main to try to figure out what the thing is I should run. I'm actually going to run Node. I'm gonna normally I would capture standard in and standard out here so that I can send them back as logs and process them as necessary. Like remember, a GitHub Action is going to look for special output tags in the standard out, so it needs a chance to get a hold of it. Just set up the environment variables. You just have to put them with equal signs, and then I run the thing. And you can see here, it didn't do what it was supposed to. Something's wrong. I didn't really finish this thing. This is, it was sort of some exploratory code to kind of get the structure right. The next step after this is going to be a proof of concept where you would expect the action to run correctly and do the thing and maybe string a couple of them together, etc. I didn't really follow this thread too far, but I actually executed Node and I, read the JavaScript and it did some stuff and tried to read my inputs and had some problem. So actually, I'm going to return. I'm going to just let that plugin go. And I return here and I got an error. And that error was exit status 1. And here, since I had captured, since I would capture standard in and standard out, those get shipped back as part of the trace. The trace is the return from that engine gRPC interface. Those will get shipped back as part of the trace in addition to like the result and the outputs that were given explicitly, in which case there were none. But I didn't catch that. So it would have these details in there in the actual trace. Okay, so that was what was inside run engine. So I actually ran an engine there in the leaf, and it's just going to do this kind of bouncing along from engine to engine, executing code. Could be a container that it'll start and with an entry point you give it, could be Node, could be one of our engines that does pulling sources, fetching cache, uploading artifacts, all those things. We're going to build those as Golang plugins that we can test and revision separate from Step Runner. And we can either have them pulled down on demand or bake them in as a local component. So that is, that's the end of the execution phase. And that's the kind of the end of the demo. At this point, I'm back out further than I started. The runner itself, you call run once, and it actually, instead of waiting till the end of that function call to get the results, that is all of the traces of each step, you give it a function that it'll call repeatedly so you can kind of follow along. So the tracer just gets individual traces of steps as they come back. So you can see here that like, if I print error, the system executed this fine, right? Like, I mean, granted, I did have a problem where I gave it the wrong inputs, but let's assume that that's like a problem with you know, the JavaScript. Like it went through the process of all this. It was able to start all the plugins, get all the plugins, put the whole thing together. It ran it. And we got sort of a natural error. And that will actually be, that error will actually be in the trace. Do I have it here? No, I didn't actually save it. All I did was print errors, so it's fine. Yeah, so that's kind of, that's like super nitty-gritty details of like how execution happens with all these things. I've introduced a bunch of new sort of terms. Engine is one of the newer ones. The idea that like components can be either engines, actions, step components, and pulled from anywhere in a generic way. And the way that we go through this process is kind of new, but it's all reflected there in the blueprint. So read the blueprint too. Give me some comments on the merge request, which I've linked in the description of this video. Tell me what you think. And I look forward to our discussion and collaboration. Thanks.